Hello, hello, hello. Welcome, welcome to another stream. Yeah, let's dive right into it, I guess. It is for sure a little complicated what we are trying to solve currently, but we will get there eventually. So I did a little bit of thinking off stream, and I think I have general idea how I would want to do it. So yeah, let's see if that works. So the idea would be that first we go to the volume like the octree generation, and here we differentiate the chunks and the leaves a little bit, or like, yeah, I mean, how do I say that? Yeah, we don't store the actual leaf nodes anymore. We just store the chunks. which basically leave nodes up to depth 10 at depth 10. Those are considered the chunk, well, chunk nodes, even though they subdivide. Leaf nodes and branch nodes at min size, or like a chunk size greater than chunk size, and branch nodes at chunk size. Let's do that. And we have that count there. And then this is the thing where we do two things. So we split that here. But this is our word octree chunk thing. That's the depth and the Morton, which we might be able to do smaller now based on this. But it doesn't really matter because I don't think it's a big deal. And then we have here a U and meshlet indices. And that is something I have to decide how many I want to have here. And then we have a U and meshlet count as well. And then this is actually not such a bad concept here. And I call it already meshlet because that's the future that I would want. For now, we will probably not do a meshlet. And then this will be ISO surface extraction request. Where we have that plus probably the U and chunk index. I'd say. Well, it's interesting because I'm not really sure how I pass that on. But do I need it? Yeah, I think I do. Maybe I can put it into this split request. I mean, realistically, that's only after level 10. So we might be able to get away with a little bit more optimization here, but we might actually split that. Maybe we do that. Beard, chunk, oak tree. And then let's do beard word oak tree. And we probably need to move a couple of things into the include here. Word oak tree.h. Let's do chunk oak tree.age. Let's do ISO surface extraction. Which will be just that. And then let's do octree split policy dot age, which will be this. More or less. And maybe we do a generic octree. I don't know. So basically, let's open all of those. So that one will be hello Capuchman. Welcome, welcome. So that will go in here basically. We have this one. Why do we have it indented? Because... Alright, so like that. And let's keep that. Let's keep that. Let's evaluate octree. Yeah, I mean, maybe. And then let's create just an octree node here. And we will handle that a little bit different. And we basically give a little bit more information here. So basically, U in depth, vec per float, node extends, node position, that is basically that. That is that. And let's give a vec3 camera position. So we don't have it like bound to the u constants that much. We still need like the sample function, which I'm not quite sure how to do. And then we have this as well. And this. It would be so nice if you can pass like functions to GLSR functions as a parameter like lambdas. But I think we just have to accept that that get sample value has to exist. Actually, let's do that outside. That lot checking, let's do that in a different function. I'm not quite sure where yet, but let's do that. Let's do all of that somewhere else. Then we have the ocg, which basically will have this and this. Which is just that. Then we do that. And then let's get rid of that basically. Because I think we don't really need that. So this is that. This is 48. This is then is far. As 1 UL or 0 UL. I think it's just UL, right? It's just like that. Shifted by 47. And then this shifted by charg 64 minus 47 is 17. So shifted by 17. No. We want to cut off the last bits of the thing at so basically we want like that, right? That's the mask we want. But what's the U inversion of that? Can I see that here in the Q calc? Is that right? But is that even correct? Why can I not copy that? Okay, I can. But is that what I want, or is it the other one I want? I think it's the other one. So actually that's not what I want. Can I somehow toggle here as well the binary stuff? Maybe not. Well, I don't know. So let's do bitwise. Not. Perfect. And then let's copy that. Oh, well, that is already a nice number anyways. Well, whatever. We fixed it. Well, let's end. Like that. Hello. So that should filter out all of the above stuff. So we can get rid of that. Then we have oh yeah, okay, yeah. Then we do here, we have this as a buffer. And we probably should include our octree stuff. Although we don't necessarily need, well, I mean, it probably makes sense to have that. Word octree nodes. No, it's probably fine like that. All right. The node count buffer. What do we use that for? Do we even use it? We might not even use that anymore. It might be a legacy thing. Alright. Legacy thing that we don't need anymore. And then we have this split stuff, which I'm not sure if I want to move somewhere. We do this here. And we probably have a layout for that. So it's more or less Is it that? I mean, kinda. Not really. It would be more like that, I think. ISO surface requests. Requests for mesh extraction. All right. Can basically copy that here. Chunk octree. Like that. The thing is, do we want to store it in one or do we want to split it? I think we will store it in one. In one big buffer, basically. But then the question is, does this even make sense? Maybe not. That one I will. Let's first figure that out, like at a later point. Oh yeah, no, we do, because we actually have different information. Yeah, it's a little bit different because that's not actually the chunk octree. It's actually where is a rename? Does it not have a rename here? Whatever. Word chunk. And then let's close that, and that is basically this. So let's put here as well word octree chunks are either leaf nodes greater than chunk size or branch nodes at chunk size, e.g. if chunk size is set to 64 meters, this ends all leaf nodes greater than 64 meters at all branch nodes at 64 meters size. Each chunk has a list of its meshlet buffer indices. All right, so I think that works so far in my mind. So let's get back to that. Let's actually now do as well the nicer. Let's put that into common. Maybe not. Let's put that into its own. Indirect dispatch and indirect draw. And let's put those as well in there because that's like actually anyways as well annoying. That's here. Can I do a struct vk indirect dispatch? I don't know, let's call it indirect dispatch buffer. I don't care actually about that. So we've got that gone. I think that is already in the word octree, right? Well, actually, no. Did I put that here? That should be here. And then this one is actually that. Yeah. All right. So this is mostly some cleanup so that we have it a little bit easier to wrap the chunks nicely. So that goes away. Then we have the whole split stuff, which I think stays the same. It's just that we need to, in the last level, we need to do a special one. Where I'm not sure exactly. So the idea would be, because the ISO surface extraction, it needs to know which chunk it needs to write its index into. So when we create the ISO surface extraction, we need to know basically what chunk we are at. Which in the word octree is easy. But in the level below, it's not that simple. The question is, do we make it just think it doesn't really matter. I think we can make it for now simpler, and then if it's a problem, we can deal with it. Don't save. Compute volume. Build word octree. Let's put that here. And then this is basically a U and chunk index. Then let's get rid of that. Let's do a couple of includes. And we probably move that to the common. Includes. Like, actually, bindless. And then here we actually do the thing where we put all the extensions into common. This one, I have no idea if it stays here. I have really no idea why it even is here, but whatever. Then let's always include here as well the common. Just to be sure, and then everywhere where we currently include common, we might need to bindless probably. Probably bindless. Probably bindless. But that's not all, or? I mean, that can't be all of them. I can't imagine that would be all. Are we not using it in ImGUI as well? Yeah. Free depth. I mean, although we are not sampling anything here, so do we even need to do that? Oh yeah, because of the few constants, right? Although, yeah, that could actually go away. Probably this one actually we can delete, like an old one. That one bindless. Probably bindless. Not sure if we actually, but let's actually change all of them to bindless. I think it's more, it's safer like that. Static mesh. I think we can delete that one as well. Let's do here bindless. We might want to do a pass on that if that is actually really what we want, but for now let's keep it easy. Because we might not need that per se, but whatever. So probably we get a shit ton of errors now anyways, as soon as we start. Let's first try to get Let's try to get all, well, the generate working again. Like this one. So here we need to includes volume octree, well, word. What did I call it? Word underscore octree dot age. That one will include octree.h, which is fine. And then we want to as well do includes word or the octree split policy. And probably ISO surface extraction. And that might be it. And then we do here and include common.age, and we should be able to get rid of that, which is already nice. So then the only question remaining is, let's close all others. Cancel. Close. What is that? Oh yeah, that's that. Okay, so now we can probably close others. Perfect. Let's bring that back. And let's see. So word chunks octree is still the same, right? I mean, we can try to just see what happens if we build that. So that would definitely not be that anymore. That would be this one. Okay, so yeah, we need to actually include that one as well then. So we need this, and we need word, or not that, but word chunk dot age, and then word octree chunks like that. We do all of this. Probably move that down here. And add another one here, ISO surface requests, probably. Yeah. Not sure if that works, but let's see. This is getting huge already. Wondering if we can do a couple of things that we just do a little bit nicer here, but I don't know. All right. Um, so if we are the root, we do that. If we are blah blah blah, we do that. Do all of that. This is not evaluate anymore. Ah, yeah, do we do the octree split policy here already? Yeah, we do. Well, it's, I think, still evaluate, right? Yeah. But we need the node extents and the node position. So it's start and the node extents are... Do we have them here? Yes, right? Isn't it u constants node extents? I think it is. And we get all of that back. And we can do a little more here. So that one goes into word chunks. Octree, right? While in that word octree's chunk. That's a little bit confusing. We should definitely make that better. Word octree. Okay. So that would be word octree. That would be word octree chunks, word octree chunks. Ah, yeah, I hope that really works, because otherwise that will be a pain if I have to find a better name for that. But I am afraid we will not be able to do that. And then this has chunks inside, right? Yes. And we basically do that. This is that. This is that. And then we do this packing here of the octree nodes. And that's about it. This is a word octree chunk where we do that, yes, and that's the leaves index. Or do we need that here? Wait. No, right? Yeah, no, we don't. But it should be 0 here for the little meshlets. I think I need a size then for that, right? Or do I not need a size for that? Maybe we do meshlet offset for now. We can maybe do it like that. And we just do 0 here. And then, so in this case here, so that's the word octree. If we come here, we want to split. But one of the nodes doesn't split. Or we don't have that case right now. So I think we can actually disregard that. This case does not exist right now. So here it's really that we are a leaf. So we do that and we do a U constants, ISO surface requests, and we basically do one of those as well. Requests, is it written correctly? That looks so wrong, but it looks fine. ISO surface requests, count 1. Now we do that, and we do an ISO surface request where we do this plus leaves index, which is our chunk. Right? Right. I think that makes sense. And then we pack our octree node. We do the dispatch of the next lever. And that's more or less it. The only thing we need to do is when we write our split here. Here we need to do our index. But that's not the chunk index. So actually we don't do that. It would be here. Or kinda not. I mean, yeah, we can do a 0 here because it doesn't matter. Chunk index does not matter at this point. So set it to 0. It matters here when we want to subdivide, but are at the max depth of the word octree. So we basically do that here. do one check here. Bool is max depth. So we do that. Now we still evaluate. We still do all of that. We do all of that, but then we have to do this here, where for each, so if is max depth, then we basically do a U and chunk do this, we do this times 8. Because we will always... Will we always do 8? I mean, kinda, right? I think. Let's keep it as very simple here. So we will always do 8. This is the first one, so then this is this plus I is our chunk start index. And then we do this. If is max depth, we write here at chunk start index plus I. Well, I guess we could do like that, right? That should work. And then this becomes the chunk start index here. And that should work. Or at least our root. So let's see, so this becomes not this anymore, that is build word octree. It's basically that, yeah. It's fine. We can rename it to update. So we would, let's keep out the chunk tree for now. Where is my buffer stuff? Ah, here, create buffers. So the word chunk octree, it's basically still that. Yes. And then this one changes a little bit. word chunk, word octree chunk. And let's see, what did we do there? It's a U in 64 and a U in 32. Morton index, U32 depth, U32 chunk index. That is, yeah, that's correct. Yes, the size. Good. So that becomes word volume word chunks. Let's do that volume octree. And that is basically this plus the size of the word octree chunk. Which one? That one was C++. That's C++. In GLSL, this is just a U in 64. Is it not? I've never heard like too much problems about it, but maybe not. I don't know. Maybe there are some compilers that don't really like it. But I have not encountered them. But it can be that that is the case. And then this, let's do a struct here as well for the split requests. Why not? That should be probably in its own thing, but word octree split request. We have a U and where basically I think it's very similar to this, right? Isn't it exactly the same? It kinda is. It kinda is the same. Except for that this is an offset. What is that offset again? Ah, it's in the node buffer, right? Yeah. Is it? Hold on, split node request. Is it, or is it the depth? No, I think it really is. Yeah, it is the offset. So this is octree index. Octree node index. And that's both U32s, right? So yeah. Right. So we do that. So that becomes size of this. Plus a size. Then we create two of those. Then we have the dispatch things, and that is a mesh buffer, which we will keep the same for now. And let's see, with that we probably already have a shit ton of errors. So let's try to get it to run today again, and then probably that's it for the stream today, because we will probably be busy with that for quite some time still. Octree leaf node. So that is not correct anymore. So that would be ISO surface extraction request here. Don't think we need that here. I have no idea why that was even here. Like, I think it was a legacy thing. Includes common.h. Can get rid of that then. Now we can get rid of that. Can get rid of that by including indirect dispatch.h. We can get rid of that. And then this is ISO surface requests. And indirect dispatch, yes. And then this is like that. And this is requests.count. That should work. Then we have here probably something like that. Yeah, I'm not sure how to sort those. We get rid of this. Oh, and we need the indirect draw now. And I think the dispatch we can get rid of. This goes away. Oh. Indirect draw. I mean, that's pretty nice how we restructure that and make it beautiful. But we will be quite in a lot of pain probably. So that goes away. That becomes indirect draw buffer. Indirect draw. Then this, and this is ISO surface requests. And then this, let's get rid of that. We don't have that logic anymore. So that becomes indirect draw. Right, and that. Requests. Great. So that's not this anymore. It's an ISO surfacing thing. surface request. Then we do all of that. We keep all of that. This is indirect draw. Like that. Oh, where? It's this, right? Because I think yeah, I think it's this, and then here as well. It's this and that. I think that is maybe everything. I have no idea. Let's see how many mesh errors we get. How many shader errors we get. Probably quite a lot. Ah, that is interesting. The first, like the basic shaders are compiled. That's fascinating. But that one didn't. Okay, yeah, that's what I thought. So here we have in union.age. Which one? Generate volume? Union.age. Why? Ah, it's probably... Wait. So which one do we include before the union? The isosurface extraction, right? Because the test SDF function is the one that includes the union. Where is my test? Oh, here. Yeah, exactly. So it's here. Oh, this one needs a semicolon, right? Don't they all need like a semicolon at the end? Yeah. Perfect. Volume, shader 50, count, no such field. Okay. But that means we are pretty far already if it's the channel. That means the build word octave shader passed without problems. But I mean, that would be insane. Wait, 50. Ah, this one, right? That one doesn't exist. Oh, this is where garbage. So is that correct now? Indirect draw, vertex instance, first vertex, first instance, first vertex, first instance, vertex instance. Oh, wait, this is garbage. Should be like that, right? I think. Then 123 and generate. 123. Yeah, sure. Makes also a lot of sense that I did that wrong. Okay. Oh wait, we are not probably... now the shader is invalid, okay. Why is that? And why do I not get a proper arrow for it? Build word octree shader. Isn't that what it's called? That looks fine. But I guess it's not. Oh, okay, here we have some errors. Not sure why I didn't output them instantly, but okay. Octree split policy. Yes. That will be a float threshold. Like that. Complex surface threshold. And then we go into our build. And... well, actually, no, sorry. That one goes all the way. Can it go to the bottom? Does it need to be ordered? Or yeah, I think it does, right? In a maybe we can forward declare. I have no idea. Maybe that works. And here we have as well probably a U constant, right? Yeah. Float geometric error. And then here we give float max geometric error and float complex surface threshold. Was that the last one? Yes. All right, and then we need to go here. Geometric. Where is it? Oh, here. And U constants, complex surface threshold. So that should help. Okay. Get sample value, no matching overload. Yep. All right. I think I know what that is. We need to include that one before anything else. Voxel offset, no such field in octree split policy. Right. I think we have that though, right? Wait, did I not? Oh yeah, no, isFar has a boolean here. Now we do that. I'm not sure if we will ever use that flag, but it's good to have. Alright. Split policy. Is somewhere here. This is node position. Do we still have it somewhere else? No. Oh, we do. Extends unknown. What? Oh, because it's called node extends. Of course it is. Pain, but it will be good once it's done. Once we have that done, I think we are in good territory. $36. Okay. Yeah, that is this. Oh no. Right. Let's do surface requests maybe. Let's do word chunks. Or let's do just chunks. Let's do oak tree. Oh wait, this doesn't even exist. Chunks. Oak tree. Chunks. Might work. That is just an oak tree node. I probably missed one or two here. Oh well, here I already did. So that's chunks. That's surface requests. Maybe. Wait, what? Oh, I did fix that. isosurface extraction.h. Shouldn't that work? What? Unexpected identifier. Why? Or is it indirect dispatch buffer? Oh, we're not doing that. Yes, okay. So here includes indirect dispatch dot h, and then okay. But then maybe that works. I mean, we can leave it with surface requests. I don't really care about that. Actually, I don't really care about that, how I renamed that. I think it makes actually sense. And it's not that bad. Okay, that is better. That makes sense. I didn't trust that. Then I think down there it's like that. And that already should be better. And then we have 135. Okay, we are pretty much at the end. Chunk start index. Now that should be fine, huh? Cannot convert parameter 2 from uint64 to uint. I set a uint here and it just doesn't want to do that. But is that really what I did? I mean, yes. Children offset. Oh, because the children offset in there is a uint. No. Yeah, then let's not do that, I guess. We will never have that many children anyways. Who cares about that, right? That would be actually just 32 bits. I mean, at that point, just fill it in. And it's like, how many are unused then? 64 minus 17 minus 32, 15. 15 bits unused. Alright, that was expected. Because I think we are not filling... We are not filling the buffer. We're still live, yeah, we are. Don't do the thing where my GPU crashes and I keep streaming, or I think I'm streaming, but I'm not. So it's that we need a new buffer here, which probably is as well an temp one. ISO surface requests, which goes here, SSBO ISO surface request. Requests. Volume ISO surface requests. And that is, I mean, yeah, it basically is that, but let's create one. ISO surface. And that is the depth and the chunk index. We do that and we create, or that one we rename to Octree chunks buffer. And then let's create one here. ISO surface requests. And then we need to adjust our push constants here. So those go down there. And then we have here chunks, Octree buffer, chunks buffer, I don't know, let's call it that. And then here Onyx U64 surface requests. All right, that's our Octree buffer. That's our chunks buffer. Then we have the indirect dispatch buffer. And we have the ISO surface requests buffer. We basically do that always, shader read write. Then at the end here, just do a shader read. Now we extract here, this is ISO, well, surface request. Mm-hmm. For now, we don't need this, like the buffer for the chunks, but we will need that. So I think that should be everything. We might not crash now. Hopefully. Oh yeah, perfect. I mean, that is expected because we didn't generate the smaller chunks, right? But we have the word octree again. So that's good. And then let's try to do the chunks, and then we are basically done for today. And then we have everything in place, I think, to iterate over the chunks for the edit. So it's very similar to the normal chunk tree, where we get still a lot of information here. We probably leave that. We leave all of that. We can remove the root stuff because we are never a root here. We can remove that logic here because again we are never a root at this point. So this is U in 64T. We can remove that. We can remove the center position. U and vec 3. Octree flat index child count. Ah, it's here. U and child count. Octree node. Alright, and now we keep going here. We keep asserting here, that's fine. Well, printing an arrow here. We keep doing that. If we are at the max depth, we don't do that for sure. And we don't push anything into the chunks anymore. We don't do that. Instead we do a surface request with our, where we get here our U and chunk index is our split request. Chunk index, and then this is here. And this is here. And we forward that down to the next one. This goes away. We still do all of that, that's fine. Yeah, I think that works. Let's do here as well in the word octree. I mean that all is nice and dandy. Let's see. I think there was one thing I wanted to do. Maybe not. I mean, let's put one space here. And let's go to the evaluate. Because basically I need to do this. I mean, this one I can do outside, but this load check would be nice to do inside. So let's do that. And let's give the camera position here back 3 camera position. Because that's the only thing that's missing, right? Well, then we actually don't need to do that here. So here, where is it here? U constants camera position. U constants camera position. If is max depth. As we do that. Well, actually, it's more like that, right? And then here, that will be our path here. So basically we set everything like that. The leaf mask to 25. 25. 255. Perfect. Then let's go wherever we have our thing here. So this one. Tree update word chunk shader. I'll uptree, yeah, walk tree chunk shader. I don't know. It's fine. It's not rocket science. Then wherever we load that. Word octree update. Word chunk. Word octree chunk update. And that is build chunk octree. And then we enable that again. Here we bind that one. And we basically do the same thing, except for that we need the surface requests here as well. I don't know, where is the offset after the node extends? Yeah, I think that's that, right? Or not really, because we do it here, but yeah. I think that's everything. I think that should work again, that we generate the sphere. Well, if I didn't make a build word octree. What? Oh, did I not save? Yeah. There it is. Okay. So we got everything back. Just that we split now stuff into chunks and into the normal octree. And with that, we should be able to now go over all the chunks. Find which chunk we need to change when we paint here. So that was the main reason why I did that. So we get our hit position. And then based on that, we will... Yes. Yes, well... Yeah, for, in general, changing the terrain. So we only do, like, the parts of the... Like, so that we only update the parts of the terrain that actually changed. Because before, everything was, like, one big... thing basically, and if I click now here, I couldn't really know in an easy way which parts I need to update, because I had just a list of leaf nodes, but at this position there is maybe 100 leaf nodes and I need to find all of those in like a compute shader. And now it's still kind of that, but we have like bigger chunks, so like 64 meter blocks or bigger. And then I just say, okay, this edit touches those 4 blocks and we are only updating those 4 blocks, basically. That's the gist of it. So it's a little bit more sane to do that now. So that is basically this. And then we do here a shader that we will kick off. And that will be... how do I call that? Q chunk updates. More or less. That will be 64. That will be 64 in size. Or do we need 64? Is that realistic? Yeah, I mean, no, let's leave it like that. We don't do that. We don't need any of that, I think. We need the hit position. We don't need that, we just need a float brush size basically. And the hit position. I think that's everything we need. Well, and we need the this one, the word chunk thingy, and we need the common, because then we can get rid of that. Do we still have that here? Oh yeah, that can go away. So that, and then here as well, basically just that. The question is that faster? Yeah, I think it's still faster to do it like that. Probably. I mean, yeah, no, it's definitely faster than that. And then we need this here as well, actually. So we need here as well the word octree chunks thing, just so that we can kick off the right amount of changes. So we as well need includes, actually we can copy it from here, indirect dispatch. And then we have this plus an indirect dispatch buffer. Where we basically say u constants indirect dispatch x y z, and then if we hit something, as we do set this to false. Here we set this to true. And now we do an u constants indirect dispatch here. We set that to u constants chunks count divided by 64. Like that. and then this will kick off this one. Where we don't do any of that crap. We just do something very similar to this shader here. Where we get this basically. Or exactly like that. Oh yeah, we need another indirect dispatch buffer, indirect dispatch. Right? Kinda. Maybe we need something else as well. I'm not sure yet. But basically we go here. This one is basically as long as we are not above the chunks count, we keep going. And then we get our chunks here. This is a word octree chunk. That one has a depth, I think. Yes. And we have a Morton. Is it Morton or Morton index? I always forget. It's Morton. So that should work. Okay, then we need a root size here. Float root size. We get that. We do this. We have Morton not included. So let's do that. Then we do this. That's the leaf coordinate, and that is our leaf center. Perfect. And then we do vec3 distance is our leaf center minus our hit position. And then let's actually add that now, because I am sick of it not having it. Oh, we already have a math here. Vector. I don't know. Linear algebra. We could call it anything like that. I don't know. Let's go to vec3. And basically bring over... Oh yeah, actually it's the dot product, right? So I don't actually need to do anything. It's the dot product with itself. Let's not do that. I always forget that. That's a thing. So we go back to our queue. Then we do... Well, that is... yeah, this. Well, that's not that, actually. Sorry, that's the direction... to hit I don't know. Well, it's not really direction. I don't know, it's something. Let's call it there. I have no idea what I would call it. Anyone has a good idea? And then we have a float is squared. Distance is dot delta delta. And then we can do if our squared distance is less than our brush size squared. For now we do like a spherical check, right? It's not exactly accurate probably for all brushes, but yeah. So then update this chunk. So basically what we do is, yeah, see, so that's a bit of a, so how would I want to do that? Do I have everything to fill out a split request? Split request is a Morton, the offset and the chunk index. But if for the chunks this is exactly the same thing? No, it's not. Or is it? No, it's not. So I have the Morton. I have not my own offset. Or do I? No, not necessarily, right? They're not necessarily matching. Oh wait, I have to look here. Because yeah, I don't have this here, right? That is child offset of the octree plus the valid index, which is always 1. So I think it might actually add up to be exactly the same. Although there might be... wait, is it always the same? It might actually be always the same. So we might have everything we need. At least I think it might work, but I'm not 100% sure. We could actually debug that by outputting it or looking at render doc if it's always the same. Although I don't output that. Oh no, it would be in... It would be in... like a surface request probably. I would see it. Wait, maybe not. Maybe I'm mistaken. So that one is... what does that have again? That's the Morton and the depth. And the index. We could store that. I don't know if that makes sense. Octree flat index. Actually, I think it might actually, as I said, it might turn out to be exactly the same. Maybe I'll find a better way to do that. So what I would want to do is queue this as a update. And that would potentially change the tree. And the leaf, like the leaf, not the leaf, but the... yeah, it would request new surfaces potentially, which is fine. That is the easiest part. The change of the octree is the more difficult one currently. I mean, I guess it would be an update of the whole chunk. Maybe that split of the two shaders was not the smartest, or maybe it was, I'm not sure. The thing is that this one builds hierarchically, oh my god, that word, from the topmost level to the bottommost level. But this one potentially changes levels in like different, yeah, parts of the tree basically. Which is fine. Maybe actually. How about we don't do it like that? Maybe instead of doing it like this. Let me think. Maybe instead of doing it like this, we do we go from the octree route, traverse down to find the largest branch that encapsulates the brush size. But I mean, basically not that, like find the branch that encapsulates the brush size tightest, basically. Find the branch that fits the brush size exactly, or like tightest. Because then we are at a certain level, we know that nothing on top will be changed. And we go down from there. And run this. Or like a similar approach to this. Does that make sense? Maybe that's a little bit stupid. And it's not necessarily true, right? That this is correct. Because what if we remove stuff? Then we might need to collapse. But yeah, that would probably work. It's not the smartest. Maybe this is still better. I'm not sure. Maybe that's something I will investigate for tomorrow. What's the time? Still, I should start sooner on on Saturdays and Sundays. It's really annoying that I'm getting hungry already. Should maybe start right after lunch to get some more stuff done. I mean, we did a lot of stuff, but yeah, not really a lot of new stuff. We just restructured it a little bit, cleaned it up, which is still nice. But yeah, I mean, it's a good thing that we did, because it makes it a little bit more sane to reason what a chunk is and what an octree node is, etc. Let's actually go there. I think it should still start, hopefully. Maybe not. Why not? I'm not referencing that one. Oh, I'm referencing that one, right? So let's not do that for now. Although, I mean, if I'm not accessing it, should be fine. That should be fine, right? Does this start again? No. Why? Ah, well, yes, you're right. Okay, so we are running again. And then let's see if we... Actually, let's do it here. If this is not the chunk index, let's debug print something. Chunk index does not match child offset. Oh wait, that doesn't, that makes actually sense. It can't match. Or? Wait. Oh, not here. That is garbage. That is the wrong one. Would be here in the word oak tree. And here it maybe matches actually. And then here as well. Chunk index, and then basically this is here that this matches the flat index. Think. Let's see if that actually does something. What did I do here? Copilot, cool. Okay. Undeclared identifier 145. Oh. Fair. But yeah, I will call it a day then, almost. Man, did I not change everything here? No, I did not, of course. Oh, I should actually change that. Okay, but it doesn't match. Well, that's unfortunate. Let's do two things. Let's first... Where are those debug prints? This one we get rid of. I think that was the only one that was interfering. And then let's put in this one. %u, %u. And that is chunk index and octree flat index. And I think actually, yeah, as I thought, it doesn't really match. Did I make a mistake again? No. Okay. Okay, yeah, it's quite a lot different. I wonder why though, but maybe that makes sense. Oh, because... yeah, okay, now it makes sense. Because we only do that if we are at max depth, right? So it is always off. Question is, do we have space to fit that? We might actually. If we change it that this points to the word octree instead of to meshlets, then we could point to the word octree. And we can reuse the 15 bits that we have to point to the meshlet. Maybe we do that. But we will do that tomorrow. But I think that's a good idea. Changing this, that this is the octree index. At which point it is basically the same, I think, as the split thing. Oh, what can you do? Yeah, no, not quite. Not quite, yeah. Or is it? Actually, it is, right? Because that's the offset. Oh, but we have the depth. No, yeah. So that's different. But with that, we can get back to our octree node, which we can then use to launch updates on. Yep, that makes sense. I think that works in my head, at least. Let's find out if it then actually works in the end. But yeah. Thank you very much for joining. Yeah, we will see each other tomorrow again. And then we will hopefully get to the edit. I mean, we are there, but yeah, hopefully we can do the edit. I mean, in the sense of we edit and we see something. All right. Yep. Have a good day as well. See you tomorrow at 7:30 as usual during the week. And I hope you have a nice rest of your Sunday. Bye bye.